So now at this point, you guys have seen enough applications. So along the way to here, there will be times that you face with those problems where setting up the intervals is easy, but then advancing to it is seriously a challenge. For example, let me bring you in something like this. Think about it as far as the application, you should be able to set it up at this point here. Let's say you got a circle, right? Center at about 2, 0, okay? And then with radius 1, for example. Okay? And so that gives you a circle exactly. Okay? And then what if you're going to rotate that region? You're going to rotate that region around. Now you're going to end up with a sort of like a donut, right? See what I'm saying? That. Every curious about the calculating the volume of those donuts from Krispy Kreme or whatever. That's the way to get there. You take it, slide it out, right, and look at the cross section right here. And there you can. So here with the problem with this, you can go with the. You can either go with the slicing methods, right? Cross sections with the slide picker as washer, because anywhere that you're rotating like that, then you got washers, right? Or if you go with vertical slides to be parallel with the rotation axis, and you're looking at the shells methods, right? But let me point out for you, either way, it's going to face you either way on this particular problem. The setting up is not hard, but it's going to take you into something like this. Say, if I choose a shells method, right? If I go with the shells method, then we're talking about, remember, 2 pi times x. It's from the rotation center out to anywhere that is, right? That's x, so 2 pi times x, 2 pi radius. Right? That's the circumference of and then we multiply with the height being you see this curve right here is circle radius 1, right? Center at 2, 0, so the equation for this circle is going to be x minus 2 all squared plus y squared equals 1. That's it. So we can break that into the upper curve. Is going to be precisely, think about plus and minus, right? Square root of 1 minus x minus 2 all squared. You got plus and minus. So the minus 1 is the bottom curve. And the plus 1 is the upper curve. You guys see what I'm saying? That? And so in that way, think about it. It's going to be, when you're taking the height of your shell, right? It's going to be 2 times of that square root, 1 minus x minus 2 all squared. What I'm saying, no? So the length of the strike, right? I mean the length of the roll, the shell rigger, multiplied with the height, right? That gives you the lateral area, and we multiply with the thickness dx here, right? And then we're accumulating from 0 to whatever the last point here. I mean, actually in this case it's not 0. The closest slice we can put, right? The closest shell we put is a 1 measure, right? So I'm rotating from. Calculating from 1 to 3, right? So we got the setup done easily, but calculating this setup like that is no joke, right? It actually takes some technique to get. Right? Trust me, take that paper, write that on a paper, go home and try that.
Professor, I have a question.
Yeah?
So the radius of the shell, I don't think is always going to be x, because that thing changes depending on which slice you're looking at.
Yes.
So
that's why but it's always, anywhere that you hear, it's just x, right?
No, but the x does change, right? Because it's 1 to 3.
Yes, it changed, but it changed only in that region. See what I'm saying? So generally we just call it x, because x itself changes, right?
Okay, yeah, that makes sense.
Okay. And by the way, it should be a 4 pi here, from 1 to 3. And then now you got, see, when you're simplifying it down, it becomes an interval like this. So my point is that setting up is sometimes quite easy, right? Setting up as an interval to get your need with this, right? To do your application problem is simple. But now when you really get into finding the antiderivative work and do the fundamental theorem of calculus, this interval is no joke. Right? I'm talking about any of the technique we've done so far, it's not useful. Okay? And so you guys can bring this home and give it some thinking with that. But this is the reason why we need to swing back and learn some more techniques for integration. Okay? Some techniques to find anti-derivative. Because up to the substitution rule that we've learned, it's still not enough to cover all of the integral problems of that. See what I'm saying? Huh? So by far we have learned just about with whatever we have learned, we can only handle about 80 to 85% of the integrals out there. Okay, and then after the quarter is over, I can ensure you about 90 to 95% of the integrals you can handle, and there's still somewhere about 5 to 10% of the integrals out there completely impossible for doing that by hand. See what I'm saying? Huh? Like I've been mentioning since the beginning of the quarter. Okay, so with something like this. Yeah, we need special technique. So, of course, it's not coming today yet. But one of the technique we need now,